Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. Mars exploration rationales and goals, guideposts for better understanding of the potential existence of life on Mars. The focus points as follows: investigation of the possibility of life on Mars, preparation for future human Mars exploration, Mars climate characterization, and characterization of Mars geology. The universe, referred to as the totality of existence, and believed to have begun billions of years ago, has received tremendous human exploration efforts targeted at understanding if life ever existed anywhere in the universe apart from the planet Earth. Mars, the most similar planet to Earth in the solar system, is receiving high attentions from researchers, scientists, explorers, government, and private space organizations based on its possibility to offer an answer to human perception of life existence on the red planet. Some of the scientific rationales behind Mars exploration are to determine whether life ever existed on Mars or if it is habitable, to characterize Mars climate and geology, to understand the surface and the planet's evolution, and to prepare for human exploration in the future. Recent data from Mars Global Survey suggests that liquid water may exist just below the surface in rare places on the red planet, and the 2001 Mars Odyssey is mapping subsurface water reservoirs on a global scale. A top priority in exploration of Mars is understanding its present climate, what its climate was like in the distant past, and the causes of climate change over time. In the area of characterization of Mars geology, plans are being mapped out to understand how the relative roles of wind, water, volcanism, tectonics, cratering, and other processes acted to form and modify the Martian surface. To pave the way for human exploration, the 2001 Mars Odyssey is analyzing the radiation environment on Mars. This mission and the Mars Reconnaissance Orbiter will continue to search for water resources that, if discovered, could be used to support future human explorers. Investigation of the possibility of life on Mars. On Earth, all forms of life need water to survive. It is likely, though not certain, that if life ever evolved on Mars, it did so in the presence of a long-standing supply of water. On Mars, search is ongoing for evidence of life in areas where liquid water was once stable, and below the surface where it still might exist today. Perhaps there might also be some current hotspots on Mars where hydrothermal pools provide places for life. Agar crater thought to have deposits of impact glass that may have preserved ancient biosignatures is shown in this picture. Recent data from Mars Global Survey suggests that liquid water may exist below the surface in rare places on the red planet. Research findings show that water ice is present at the Martian poles, and these areas are good places to be targeted to search for evidence of life on Mars. Artist's concept of Nozomi, which shows the spacecraft in orbit around the red planet with its instrument mast fully deployed, is shown in this picture. Life on Mars investigation. In addition to liquid water, life on Mars also needs energy. Future missions are being designed to look out for energy sources other than sunlight, since life on the surface of Mars is unlikely given the presence of superoxides that break down organic carbon-based molecules on which life is based. On Earth, there is life in many places where sunlight never reaches, at dark ocean depths, inside rocks, and deep below the surface. Perhaps tiny subsurface microbes on Mars could use such energy sources. Architect design of futuristic spaceport suited for commercial space travel is shown in this picture. Most of the current Martian atmosphere consists of carbon dioxide. If carbonate minerals were formed on the Martian surface by chemical reactions between water and the atmosphere, the presence of these minerals would be a clue that water had been present for a long period of time. Life detection technologies under development will help to define life in non-Earth-centric systems so that we are able to detect it in all forms, is my take. Earth to Mars laser communication system is shown in this picture. Mars climate characterization is another rationale behind the Mars exploration ideas. A top priority in exploration of Mars is understanding its present climate, what its climate was like in the distant past, and the causes of climate change over time. The current Martian climate is regulated by seasonal changes of the carbon dioxide, ice caps, the movement of large amounts of dust by the atmosphere, and the exchange of water vapor between the surface and the atmosphere. An orbital view of the North Polar region of Mars is shown in this picture. Mars climate characterization. One of the most dynamic weather patterns on Mars is the generation of dust storms that generally occur in the southern spring and summer. Mars dust storms can grow to encompass the whole planet. Understanding how these storms develop and grow is one goal of future climatic studies. Mars global climate zones is shown in this picture. A better understanding of Mars current climate will help scientists more effectively model its past climatic behavior. To do that, we will need detailed weather maps of the planet and information about how much dust and water vapor are in the atmosphere. Monitoring the Mars planet climate over one full methane year, about 687 Earth days, will help us understand how Mars behaves over its seasonal cycle and guide us toward understanding of how the planet changes over millions of years ago. Illustration of large dust storm on Mars is shown in this picture. The layered terrain of the Martian polar regions holds clues about the Mars planet's past, much like the rings of a tree provide a record of its history. When and how were these polar layers deposited? Was the climate of Mars ever like that of Earth? And if so, what happened to change the planet into the dry, cold, barren desert it is today? Those are the questions that missions will have to answer. A geological crater on Mars is shown in this picture. Characterization of Mars geology is another rationale behind Mars exploration. Mars geology questions to be addressed are: how did Mars become the planet we see today? What accounts for the differences and similarities between Earth and Mars? Plans are being mapped out to understand how the relative roles of wind, water, volcanism, tectonics, cratering, and other processes have acted to form and modify the Martian surface. Illustration of Mars geology is shown in this picture. A recent discovery by the Mars Global Surveyor spacecraft of large areas of magnetic materials on the Mars indicates that the planet once had a magnetic field, much like Earth does today. Because magnetic fields in general act to shield planets from many forms of cosmic radiation, this discovery has important implications for the prospects for finding evidence of past life on the Martian surface. Moving projection of habitable features on Mars from Hubble Space Telescope is shown in this picture. The study of the ancient magnetic field also provides important information about the interior structure, temperature, and composition of Mars in the past. The presence of magnetic fields also suggests that Mars was once more of a dynamic Earth-like planet than it is today. The age and composition of different types of rocks on the Martian surface are of fundamental importance. Geologists use the age of rocks to determine the sequence of events in a planet's history. Composition information tells them what happened over. Illustration of interior layer of Mars is shown in this picture. Preparation for future human Mars exploration is another rationale behind Mars exploration idea. The safety of astronauts is of paramount importance. Getting astronauts to the Martian surface and returning them safely to the Earth, however, is an extremely difficult engineering challenge. A thorough understanding of the Martian environment is critical to the safe operation of equipment and to human Earth. Artist concept depicting astronauts and human habitats on Mars is shown in this picture. Mars lacks an ozone layer, which on Earth shields us from layered doses of solar ultraviolet radiation. Humans do not have enough information about the amount of ultraviolet radiation that reaches the Martian surface. A more detailed understanding of the radiation environment will provide the information necessary to assess the effects of ultraviolet radiation on astronauts, as well as help engineers design protective spacesuits and habitats. Illustration of an astronaut working on Mars is shown in this picture. To pave the way for human exploration, 2001 Mars Odyssey is analyzing the radiation environment on Mars. This mission and the Mars Reconnaissance Orbiter will continue to search for water resources that, if discovered, could be used to support future human explorers and endeavors. Eventually, robotic spacecraft, rovers, and drones could be used to access water resources in advance of and during human exploration. Illustration of factories on Mars is shown in this picture. Advanced entry, descent, and landing techniques that reduce the G-forces on landers are being developed for spacecraft and astronaut safety. And robotic exploration will pave the way and help to facilitate long-term possibility of human missions to the Mars. Artist illustration of future Mars exploration is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Mars Exploration Rationales and Goals, Guideposts for better understanding of the potential existence of life on Mars, presented by Dr. Ayenshola Ogundele, with focus points: investigation of the possibility of life on Mars, preparation for future human Mars exploration, Mars climate characterization, and characterization of Mars geology. Thank you.